Okay, so yesterday we did increasing and decreasing, and today we're going to talk about relative max and relative min, which could also be called local max and min, or relative extrema, because it's like the extreme values, the max and the min, or local extrema. Those are all getting at the same thing. In any of those cases, your local max, your local or relative max, happens when f prime of x switches from increasing to decreasing. So if you think about that, what that would look like, f of x is increasing, it means the original graph is going up, then it starts going down. If it goes from up to down, you're going to have that like the top of a hill, and that's your relative max. Also think about what the derivative is doing at that spot. If your original graph is increasing, that means it has a positive slope. That means your derivative is positive. If your original graph is decreasing, that means it has a negative slope, and your derivative is negative. So these two are saying the exact same thing. You're going to have to be able to interpret it from either scenario. So I might give you an original and say, where's their local max? I might give you a derivative and say, where does the original have a local max? And you'd have to look at kind of both ways. That's all much harder when you look at graphs. Algebraically, it's pretty much what we were doing last class, just adding one step. So let's look at a couple examples. Oh, guess I should write the other one. So local relative min would be the opposite. So f of x would go from dec to inc, because you're going down, and then you start coming back up. So there's that bottom of a hill there. Or, if the original is decreasing, your derivative has to be negative, and if your original is increasing, your derivative has to be positive. Alright, so let's say I gave you y equals negative x to the third plus 3x squared minus 6. So now I'm saying find inc, dec, relative extrema. Find all the stuff you found yesterday, and then add to it. We're just going to kind of build throughout the chapter. We find this, and then we find concavity, points of inflection, asymptotes, put it all together at the end. So, increasing and decreasing comes from the derivative level. So let's take the derivative. And this comes from the derivative level also. So let's take the derivative. Negative 3x squared plus 6x. You would then find critical points. So at the top and bottom equal to 0. In this case, there's just a top. I would factor out a negative 3x, get x minus 2. Setting that equal to 0 gives me x equals 0. Setting that equal to 0 gives me x equals 2. Then I can build my intervals around that. So negative infinity to 0, 0 to 2, 2 to infinity, and I'm plugging into the derivative because I want to know slope. I want to know increasing, decreasing. So take like a negative 5. And I'm going to use this one. You can use whichever one you want. I think this one's easier. If I put a negative 5 there, this piece is positive. If I put a negative 5 there, this piece is negative. Positive times negative. My derivative here is negative, which means my original graph is decreasing. I'm going to use 1 here. So negative 3 times 1 makes this piece negative. 1 minus 2 makes this piece negative. So negative times a negative means the derivative is positive and f of x is increasing. Pick like 10. I make this piece negative, this piece positive. So f prime of x is negative and f of x is increasing. So you've answered that part of the question right there, because you just told me where everything's increasing and decreasing. Now relative extrema is where it switches from one to the other. So up until 0, we were going down. From 0 to 2, we start going back up. So at x equals 0, there's a relative min. So relative min at 0, comma, something. And this something is a point on the original graph that is a y value. So we don't plug into the derivative. The derivative will tell us slope. We plug into the original function. So I'm plugging in there. If I plug a 0 in there, I'm going to get negative 6. So then the function is increasing from 0 to 2. Oops, this should have said decreasing a long time ago, I'm sorry. And then we start decreasing there. So at x equals 2, we're at the top of a hill, so that's a relative max at 2 comma whatever, and to find the y value, the whatever, we plug back into the original. So this is negative 8 plus 12, so that's 4, and then 4 minus 6 is negative 2. What we're going to end up doing with these, why the points matter, we're not doing this today, but eventually, you're going to put those points on the graph. You're going to know where the graph is decreasing, increasing, etc., and where it curves in different ways. And you'll be able to actually piece that graph together and get a very good idea of what the graph looks like without using your calculator. Okay, let's look at a couple more. So let's say y equals negative x squared over 2 plus 2x plus 2. I think for most of you it's beneficial to take that extra step and write it this way because the negative 1/2 out in front is a lot easier to work with for most of you. Take the derivative. So negative 1x plus 2 is at the top and bottom equals 0, but there is no bottom. So we get that x equals 2, and we're going from negative infinity to 2 to infinity. We're plugging back into the derivative. If I plug in 0, I get a positive number, so the derivative is positive, which means f of x is increasing. If I plug in like 10, negative 10 plus 2, I get a negative number, which means the derivative is negative and the original graph is decreasing. So we went from inc to dec. That creates a relative max at 2 because that's where the switch was, and then to find the y value we plug back into the original. So 2 squared is 4, negative half of 4 is negative 2, plus 4 puts me at 2, plus 2 more puts me at 4. And all this graph is, and again, you don't have to know this right now, but it increases up until there and decreases after, so it's just a parabola. Alright, third one. This is all I got for you. Let's say x to the third minus 3x squared plus 12x. So we're going to take the derivative, 3x squared minus 6x plus 12. Let's set that equal to 0. So I'm going to try to factor it. I'm going to take a 3 out, so x squared minus 2x plus 4 equals 0. So I'm trying to multiply 4 and add up to negative 2, but that doesn't work. So I'm stuck trying the quadratic formula. And you can use quadratic formula with the numbers after you've factored. So I'm going to use 1 for A, negative 2 for B, and 4 for C. But watch what will happen. So negative B is 2, plus or minus the square root of B squared is 4, minus 4 times A times C. And the bottom part isn't even going to matter because what you get here is